Section 7.2 is titled Matrix Algebra. In this section we're going to go over first what a matrix is, and then a whole lot of basic operations with matrices, adding, subtracting, scalar multiplication, how to multiply matrices, how to find their inverse, how to do determinants, just a whole variety of different operations and things that we can do with matrices, and we're going to do it all in this one section. Now, if you were with me for Algebra 2, you know that we taught an entire chapter on matrices where the entire chapter consisted of all of the stuff that we're going to do today in this one lesson. So if there's anything that you need extra clarification on, extra examples on, I would invite you to visit Chapter 4 of the Algebra 2 sequence of videos, which is all on matrices, basically this section just in more depth. Alright, so first, what is a matrix? A matrix is just a rectangular array of numbers. Okay, so a rectangular array of numbers, maybe something like this. Okay, might look something like that. And it can of course be any size. I just made it this size, but it could be any size. A matrix has rows and columns. So rows are going across, columns going up and down. And the size of a matrix is always referred to as its number of rows by its number of columns. So this particular matrix would be a 3 by 2, indicating to somebody that it has 3 rows and it has 2 columns. Okay. So in this section we're looking at how do we deal with these matrices, how do we do things to them, how do we add them, subtract them, multiply them, and then just some other operations as well. Okay, there are 2 basic operations that we're going to begin this lesson doing with matrices. The first is just matrix addition, and I do include subtraction in there as well, so addition, subtraction. And the second is scalar multiplication. Scalar multiplication is multiplying by a constant. Okay, so it won't be take a matrix times another matrix, it'll be take a matrix times a constant, or just a number. Okay, so we'll see each of these 2 basic operations in these next 2 slides. Okay, first example says for the following matrices A and B, find A plus B and A minus B. So A plus B, if I write it out first, I've got 11, negative 1, 0, 3, plus negative 5, 0, 3, 1. Okay, we're asked to add these 2 matrices together. First, in order to add matrices together, they have to be the same size. Okay, can't add them together or subtract, for that matter. Subtraction, same. You can't add or subtract unless the matrices are the same size. So an easy visual inspection will tell you that they're the same size. They're both 2 by 2. And when we add them together, you're going to get a matrix that is the same size as the matrices you're adding. So we're going to get a 2 by 2 matrix. All we do is add the numbers in the same corresponding positions. So 11 plus negative 5, 6. And then we continue across. The next number, negative 1 plus 0, is negative 1. Go to the bottom row, 0 plus 3 is 3, and then 3 plus 1 is 4. So all we're doing is matching up spot for spot within the matrix and adding them together that way. Subtraction is nearly just as easy. So we begin with matrix A minus matrix B. Okay, again we check the size, they're the same size, so we can subtract, and just like with addition, we're going to subtract the numbers in the same corresponding position. Okay, when we subtract, we're being careful with subtracting negatives and all that sort of stuff. So it's 11 minus negative 5, which is 16. Negative 1 minus 0 is negative 1. 0 minus 3 is negative 3. And 3 minus 1 is 2. Okay, so there you go, addition and subtraction. Okay, next example is asking us to find 2a minus 3b, and here's a and b. So I would like to take 2 times matrix A minus 3 times matrix B Okay, when you multiply by a scalar, here the 2 and the 3 are scalars. They are constants, numerical constants. All we're doing is simply distributing that constant to every number, etc., in the matrix. So 2 times matrix A is 2, 4, 6, 0, 2, 8, 0, 0, 2. Minus, I'll do the same thing here, 3 times all the numbers in matrix B is 3, 0, 0, negative 3, 3, 0, negative 6, negative 3, 3. Now I'm going to go ahead and subtract them. So I'm going to get a matrix of the same size, and I'm just going to go position to position, just respective same spot in the matrix. So 2 minus 3, negative 1. 4 minus 0 is 4, and then 6 in the top row. In the middle row, 0 minus negative makes plus, so positive 3. 2 minus 3, negative 1. 8 minus 0 is 8. In the bottom row, going across, 0 minus negative 6 is positive 6. 0 minus negative 3 is positive 3. 2 minus 3 is negative 1. And here's our solution. Alright, next we're going to talk about matrix multiplication. And matrix multiplication, multiplying a matrix times another matrix, is a very unique sort of operation to perform, as the size of the matrices have to match up in a very unique sort of way. So let's say that we're taking matrix A, and let's say that matrix A has dimensions m by n. And we're taking that times matrix B. Matrix B has dimensions n by r. The product of A times B would have dimensions m by r in this instance. Okay, so here's what you're looking at. In order to perform a matrix multiplication, these numbers, which I sometimes call the inner dimension, the inner dimensions must match. If those do not match, then the matrix multiplication will not be defined and you're not going to be able to do it. Now, if they do match, and you therefore are able to do it, well then the size of the product is the outer dimensions of A and B respectively. That makes up the size of our product. So that's going to be task number 1, is going to be just to investigate the size of the matrices, and then I'll show you how do you go about actually multiplying them together. Alright, this example we're asked to find the product of these matrices. So the first thing I do is I check the size of each matrix. This one right here is 2 rows and 3 columns, so we've got a 2 by 3, and this one is 3 rows and 2 columns. So I'm looking at these numbers here to see if they match. And in this case they do match. So when they match, that means I can multiply them together, and my answer is going to be a 2 by 2 matrix. Okay, so I'm going to get set up a 2 by 2 matrix. Okay. Now I'm going to add some extra annotations here for the purpose of showing you how to multiply two matrices together. I wouldn't always do this, and in practice, once you've done this a number of times, you probably wouldn't be doing it either. But this 2 by 2 matrix has 2 rows, obviously, and 2 columns coming down. Okay, and the problem originally stated, so again, I threw away this number and I threw away this number. So what did I keep? I kept the rows here. This was 2 by 3, 2 rows, 3 columns. So I kept the rows. So I'm going to label the rows here. And in this matrix, I threw away the rows and I kept the columns. I'm going to identify the columns on this one. And the way I like to do it, especially when I show it the first time, is I'm going to circle the rows of this matrix. I'm going to circle the columns over here. Okay. Now, in order to find this number right here, in order to find the number that goes in row 1, column 1. Okay. Let me change color so you can see that a little bit better. I want to find the number that goes in row 1, column 1. What I'm going to do is use all the numbers in row 1 and all the numbers in column 1. And what I do is I multiply along the row and column in the first positions, second positions, third positions. So I take first the 3 and the 1. Okay, the first number of each the row and the column. So I'm going to take 3 times 1 plus, and then I take the product of the next numbers, 1 times 0, and then I take the product of the next numbers, 0 times negative 3. And so let's see, this one of course is 0, this one is 0, 3 times 1 is 3, that's the number that goes in the first spot. Okay. Now let's say I want to find row 1, column 2. So I'm going to stick up here in this top row. I'm going to find the second column. I'm going to find this spot right here. So I'm going to use row 1 and column 2. And again, it's the first number times the first number plus second number times second number plus third number times third number. Okay, so of course this 0 times 8 is gone. I've got 6 plus 1, which is 7. That goes here. Okay, so I'm finished with row 1. Now I'm going to drop down to row 2. So I'm now looking for row 2, maybe column 1. So row 2 with column 1's numbers. And again, it's first number times first number plus second number times second number plus it is third number times third number. So again, I just go like this. I go across the row, down the column, and I match these numbers up. Okay. So let's see, this one is 0. I end up with negative 1 and negative 15. It's negative 16. And then finally I'll find row 2, column 2. So again, it's first times first, second times second, third times third. I'll do this one a little bit faster. So the first numbers multiply to negative 2. Second numbers multiply to 2. Third numbers multiply to 40. Add those together. Of course, these cancel, so the result is 40. Okay, so there's our matrix product. I was being real detailed, writing all of this out. But normally for me, this is just mental math. I normally don't write all this out. So I don't want you to think a matrix product is an enormous amount of work to do. Normally it will go pretty fast once you get the hang of the pattern, as far as just going across rows, down columns, and pairing numbers up. Just kind of as you go, you can kind of do it that fast. Alright, this next example is another matrix product. For this one, I'm going to show you maybe how you'd probably go about finding these matrix products in practice, because you probably wouldn't do what I did by hand all the time on the last slide unless you were specifically told to do it. What you'd probably do is use some sort of calculator or computer system to do the problem. And so I'm going to show you how to do a matrix product here on this, the graphing calculator that you have. Okay. So the first thing we need to do is access the matrix menu. And for most of your calculators, if you look right here on the left edge, there's this button that says x to the -1, and above that says matrix. Bring it up a little higher so you can see it. So right here, this x to the -1 button, it says matrix. So I'm going to hit second on that button, and it brings up a menu of matrices. See if we can see that. Okay. Now what you have to do first is type the matrix in. So to do that, we use the arrow keys and we go over to edit. And I'm just going to edit matrix A. You can pick any matrix that you want. What you're going to have to do first is enter in the size of the matrix. So these matrices on this problem are 3 by 3. So I'm hitting the number, hitting the enter. And so notice it opened up a 3 by 3 matrix. And I'm going to type the numbers in. So the first matrix, the one on the left, it's 1. I hit enter. 2. I hit enter. 3. Notice it just goes across, then it goes down. So I'm just typing in these numbers. And that's simple enough to do. Okay? So I've got matrix A typed in. Now I'm going to go back to matrix. So again, I'm hitting second and matrix. Okay, to get back to this matrix menu, I'm going to edit. I'm going to pick a different matrix, and I'm going to type in the other one. It's again a 3 by 3. It's 1, 0, 0, -1. Make sure with negative numbers you hit the negative button, the negative key. If you hit the subtraction key, it will not work. Okay, so I've got matrix, the second one typed in. Now what I'm going to do is quit. So see the quit above the mode. I'm going to hit second mode, so it quits back to my main screen. Okay. Well, since I've now typed this matrix into my calculator into matrix A, this one has been typed into matrix B, I now need to tell the calculator to do matrix A times matrix B, and it will do the product for me. Okay, so here's how I do that. I'm going to go back into my matrix menu the same way I've been doing. So I hit second matrix. And instead of edit now, this time I'm going to use the names. So the tab, you see the tabs on the top. I'm just going to keep it on the one on the left. I'm going to hit enter on matrix A. That pulls it out to this screen. I'm just going to hit my multiplication button. I'm going to go back into matrix, and I'm going to highlight B. So the calculator is now going to compute A times B. There's our matrix product. Much faster and more efficient than we could do probably pencil and paper math. Okay, so there's my matrix product, and I'm going to go ahead and write that down. The result was -7, -1, 3, -9, -3, 4, -2, -1, 1. And there it is. Okay, we're going to shift gears a little bit and talk about something a little bit different. We're going to talk about inverse matrices, and a lot of what we'll do near the end of this chapter, especially in the next section going on, we're going to be utilizing inverse matrices quite a bit to solve systems of equations. So let's kind of build up to that. An identity matrix is a square matrix with ones on the main diagonal. I'll say, and zeros everywhere else. Okay, so what does that look like? For a 2 by 2, that's the identity matrix. For a 3 by 3, that would be the identity matrix. For a 4 by 4, that would be the identity matrix. And you can start to see the pattern. Ones on the main diagonal. The main diagonal is top left to bottom right, and then zeros in every other location. And so that's the identity matrix. Inverse matrices, and this is kind of where we're going. Two matrices, I'll say two matrices are inverses if their product is the identity matrix. Okay. So we define inverse matrices in the context of identity matrices. So two matrices will be inverses if their product is this, if their product is this identity matrix. So the directions here say to verify that the two matrices are inverses. In other words, show that A times B is equal to the identity matrix. If A times B is equal to this, well then yes, these matrices are inverses. So let's do that, and they're two smaller matrices, so I'm going to go ahead and do this without the calculator. They're both 2 by 2, so the answer would be 2 by 2. We're using rows on the left, columns on the right. And so this first spot, let's see if I can do this without all the extra writing. This first spot is row 1 with column 1. So I take the first numbers together and the second numbers together, so it's 3 times 1 plus negative 2 times 1, so that's 3, and negative 2, which is 1. And so far, so good. Okay, now I'm going to do the top row, first row with the second column. So the first numbers multiply to give 6, second numbers multiply to give negative 6. If I add those together, we get 0, and we're still good. Okay, now I'm going to take the bottom row with the first column, so multiply, that's negative 1, multiply, that's positive 1, and that's 0. And finally, the bottom row in the right column, so multiply, that's negative 2, multiply, that's 3, and negative 2 and 3 is 1. So when I multiply these together, we do get the identity matrix. Therefore, yes, A and B are inverses. Okay. Well, that's fine to be able to show that two matrices are inverses. A better exercise, a better question would be, can we find the inverse of a matrix? Because if we could find the inverse of a matrix, well, then we could use it in a variety of different problem-solving situations. So, finding an inverse matrix. I'm going to show you a way to find the inverse of a 2 by 2 matrix. Okay, there is a formula for a 2 by 2 inverse that's pretty easy to do, so it's worth learning. If we say that matrix A is A, B, C, D. Okay. Then the inverse of matrix A would be this. First of all, we need a fraction, 1 over, and the denominator of this fraction is going to be AD minus BC times, and in the matrix the numbers get rearranged, so we have D, negative B, negative C, and A. Okay, so that's our 2 by 2 inverse matrix formula. You notice that inside the matrix, the A and the D on the main diagonal, they just change places. The B and the C, they don't change places, but they change signs. And then we need this fraction here, which is always 1 over. You take this product minus this product, and so that will have this fractional value here. That fraction is then the scalar, and it gets distributed into the matrix. Okay, so we'll do an example of that on the next slide so you can kind of see how this in fact works. Alright, so this first one, we've got a 2 by 2 matrix. We want to find its inverse. So I begin with the 1 over. I'm going to do this product, 6, minus this product, 4, times. I take the numbers on this main diagonal, the 3 and the 2, and I switch them places. Take the numbers on the other diagonal and I switch their signs. So if I simplify the fraction, it's 1 over 2 times our matrix. And I'm going to take the 1/2 and just distribute it as a scalar into every number. So it's going to be 1, negative 1/2, negative 2, 3/2. There's our matrix inverse. It is very, very common to have fractional values show up in the inverse because of this scalar. Oftentimes will result in a fraction that gets distributed inside the matrix. Now, for matrices larger than 2 by 2, for 3 by 3, 4 by 4, 5 by 5, etc., I'm not going to show you how to do it by hand. It's beyond what I want to do in this particular video. What I will show you is how to do it on your calculator, because your calculator can find the inverses. So let's do that with this 2 by 2, or this 3 by 3, sorry, that we have here. So I'm going to begin by going into the matrix menu again, just like we did before. We're going to go over to edit, and I'm going to pick any matrix. It doesn't matter. I'm just going to pick this one because I'm done with it from the last problem. I'm going to type in these numbers. Okay, so all I've done is typed in this matrix into my graphing calculator. And then I'm going to quit. So second quit, get back out here. Now I'm going to tell the calculator to find the inverse of this, and here's how I do it. I go back into my matrix and I pull out the matrix that I typed it in, so that was matrix A. Now the button that we've been using to get to matrix has this x to the negative 1 on it. That's our inverse button. So if I just hit that button, look what shows up on my screen. It's that -1 exponent notation that we know to be inverse. So that's my inverse, A inverse. It's going to do the inverse of this matrix. Now it gives me decimals. If you don't like decimals, we know that we can change to fractions. If we hit the math button, we want number 1 fraction, so we enter, we hit enter again, and it'll change it over into fractions for us, and then we can record that answer as our inverse. So our inverse matrix, 1/10, 1/5, negative 1/2, 1/2, 0, 1/2, 1/10, 1/5, 1/2. There's our inverse. We can of course do that for any square matrix. I could even have done that for the 2 by 2, but the formula is pretty short and quick, anyway, so I'd almost spend as much time typing this into the calculator and doing it over here as I would just doing it like this if I've practiced it. Alright, the last thing that we're going to go over is determinants of matrix. A determinant is simply a real number every square matrix has. Okay, so every square matrix has a determinant. I should probably say only square matrices have determinants. And these determinants also have a variety of uses, applications that we can use them in, namely solving systems of equations, which we can do and what we began this chapter with. So let's go over on the next slide, the last slide, how to find determinants. Okay, for a 2 by 2, the determinant is a very, very simple calculation, and you've actually already done it. You did it when we did the inverse matrix. The determinant of a 2 by 2 matrix, we take the product of this diagonal minus the product of this diagonal. So it's 15 minus -2, which is 17. Again, the determinant is just a number. It's not another matrix. Oh, and one other thing I failed to mention when I was talking about determinant on the last slide, but you kind of see it here. Look at the notation. The matrix no longer has the squared in brackets. When you see the matrix just in these parallel bars, almost looks like absolute value bars, but they're not. That's indicating to you that you want to find the determinant. Okay. Now for a 3 by 3 matrix, we're going to do it very similarly. How like over here with the 2 by 2, I did this diagonal starting at the top left and coming down to the bottom right. I took that diagonal's product minus the other diagonal product. Same kind of thing for the 3 by 3. It's just that it's a bigger matrix, so there's going to be more numbers and more diagonals. Okay, so let me show you how to set it up first to do this diagonal technique. First thing I do is I take these first two columns and I rewrite them behind the matrix. Okay, it's going to help us match all the numbers up correctly. So here's how I do it. I take, just like I did here, this main diagonal, top left to bottom right. I'm going to start there. I'm going to take the numbers on this diagonal and multiply them together. So 3 times -1 times 0 is 0. And I'm going to add to that the product of the numbers on the next diagonal coming down. 1 times 2 times -3 is -6. I'm going to add to that the product of the next diagonal coming down. 2 times 0 times 2 is 0. And now just like we did here, we subtracted. I'm going to subtract from that the diagonals that come from the bottom up. -3 times -1 times 2 is 6, plus 2 times 2 times 3 is 12, plus 0 times 0 times 1 is 0. So this first set is -6 minus this next set is 18. -6 minus 18 is -24. Okay, so that's not too bad. There's simple ways like this to do the 2 by 2 and the 3 by 3. There is not simpler ways like this to do larger matrices. So for larger matrices, I just kind of default to the calculator. So let me show you how I can do that on the calculator. I'm going to go into the matrix menu. I'm going to come over to Edit, Matrix A. I'm going to just go with the 3 by 3 that's right here. I'm going to type in this matrix. Okay. Once I've typed that in, I'm going to quit to get out of there. And I go back into matrix. And this time on the tabs, if you go across the right to math, you see a lot of the different options there. The first one is DET, and DET stands for determinant. So I'm going to put enter there. I'm going to go back into matrix, and I'm going to do the determinant of that matrix A that I just typed in. And it tells me it's negative 24. Same thing that I got here, doing all the diagonals. Okay, so that concludes this section on matrices. Again, if you need extra clarification on any of these problems, I would again invite you to look at the Algebra 2, Chapter 4, where we have in much more depth all these matrix operations and things that we can do with matrices.